Pronto.
So good afternoon, everyone. Welcome to this first NITheCS Colloquium of 2025. My name is Francesco Petruccione. I'm the director of NITheCS, and welcome to the many visitors that we usually don't see in this venue. So welcome to Stellenbosch. And hopefully it's not too late to wish all of you all the best for 2025. Yeah? So this afternoon, we are very, very honored to have Professor Bruno Chiarellotto from the University of Padua with us, who will give us a very exciting talk on the life of one of our heroes, if I can say so. Yeah, Professor Chiarellotto did his PhD at University in Rome. Not sure which university.
No, at that time it was
there was
a global.
Okay. Interesting. I didn't know that. Yeah. And after his PhD, he spent some time as a postdoc in Paris, in Princeton, and at University of California in Berkeley. And since 1994, he's back at the University of Padua, where he's the head of department in mathematics, and where we share some common friends.
Yeah, that's correct.
But that's a story for another post-talk conversation. Yeah. Okay, Professor Chiarellotto, we're very happy to have you with us, and everything seems to work, which is sometimes a miracle. You're welcome to start. Thank you very much.
Thank you very much. I thank the organization. I thank Sophie Marquez who organized all this conference, mathematical conference, and this conference for open public. Even if I can see a lot of colleagues, mathematicians, and I think that I'm not going to bore all the mathematicians, but I think that Alexander Grothendieck life is actually very interesting. So in order to understand, so my point of view is the following. In order to understand the way how Alexander Grothendieck worked out his own mathematics, is important to know his background, mainly his family and his complete life. So this is a picture of him, okay? And as I said, let's start with his father. His father has the name Sasha Shapiro, was born in 1889 from a Jewish family in this, don't ask me to say this word, is Novozibok, which is now, that at that time was under the Russian Empire. Nowadays it's still in Russia, but is in this part of Europe, which is between Russia, nowadays Belarusia, Ukraine, and it was a part which passed from Russia to Poland, to Ukraine, and so on. So he was really in the middle of a lot of countries. And this father, when he was 16 years old, he was a member of an anarchist group, which was fighting against the Tsar. They were captured and sentenced to death, all of them. So his friends were all executed, and it seems that he has to attend all the execution. But Sasha Shapiro was young, so they decided not to kill him and to give to him a jail for all his life. But in 1917, the revolution in Russia made a lot of changes. So it means that it was a chaos, a big problem, and so Sasha Shapiro could get out from the prison, but not just to go in some remote place and to grow vegetables, so tomatoes and so on, but he started again to join an anarchist group. This group was rather peculiar. Let's say the chief of this group was General Mebkhout. Mebkhout was an Ukrainian. So he was an anarchist group, but it was made not only by anarchists, but also by farmers and peasants, Ukrainian peasants. And this group was fighting against both the White Army and the Red Army. They were fighting everybody because they want to be, let's say, free. So, and again, our Sasha Shapiro was captured and sentenced again to be sentenced to death again. By the way, along all these fightings, he had a lot of nom de guerre. So he was Alexander Shapiro, Alexander Tanarov, Sasha Piotr, Sergei. He had a lot of names, and we will see later these names, how they will appear. In 1921, he escaped. He had no documents, he didn't have any passport. He lost one arm running away, and he went to Berlin, Paris, Belgium, and under the name of one of the nom de guerre, Alexander Tanarov, and he was a photographer. In 24, he was in Berlin, and then he met Anka Grothendieck. Anka Grothendieck was let's say, a bourgeois, let's say in this French way, but she was a writer, an anarchist, and a writer in a newspaper. And at that time, Anka Grothendieck was married with Alf Radatz. And it seems that our Alexander Shapiro introduced himself to the husband in I will steal your wife. That's what the sentence. Of course, he was sentenced to death twice. He didn't have fear of this. So, and he kept the word, actually. So let me give a picture of him in Berlin. See, in 22, you see, you don't see the arm, of course, because he was lost. Okay, this is a picture of Anka Grothendieck, and this is the first on the, and sorry, what happened? Okay, and she's the first on the left. Okay, after 3 years that he met Radat's family, Alexander Grothendieck is born. Actually, Anka Grothendieck was still married with Radatz. So at the beginning, Alexander was Alexander Radatz. But Anka Grothendieck decided, of course, to quit her husband and to live together with Shapiro. And they lived together, actually, Anka, Shapiro, the young Alexander Grothendieck now, and another Anka daughter with the name Maida Radatz. Then in 1930, Hitler was rising to power, and Shapiro was a Jewish anarchist, so someone making a lot of troubles, and illegal. So he ran away, and he went to France. France, which was a good place for all these people at that time. Anka decided to join him around 1933. What happened to the kids? No, she went alone. So the kids, they stay back in Berlin. Alexander and his sister, Maida. Okay. Then the two, I would say the two, not the sister Maida and Alexander, they were 5 years old, but Shapiro and his wife, later they moved to Spain. They were involved with the civil war, but of course they were not really fighting, but still they were there. What happened to the two kids now? So, and now there is something that I want to stress all along my talk today. Grothendieck didn't have a really peaceful life, okay? But always he had big luck, okay? So, and for example, his sister was sent in asylum for disabled people, while Alexander was sent in a foster home care, which was organized by Pastor Wilhelm Haidor in Hamburg. Okay, you said, if something would have been happening to me, I will end in the middle of nowhere and nothing to do with someone who even doesn't know how to speak or something like that. But in that case, for Grothendieck, what happened? This guy was really an exceptional guy. In fact, Pastor Haidor was a peculiar figure. We have even a biography for him. He was a first army officer, after a priest, and a practitioner of alternative medicine. You have to think that at the beginning of the Nazi regime, this alternative medicine based on natural plants and so on was really, really welcome by the Nazi culture. He was going back to the roots of the German life. So at the beginning, they were really friendly with the Nazi regime. He was also a founder of a party called Humanity Party. But unfortunately, this was in the beginning of the 30s, 30, 35. But later, this kind of alternative medicine and this Humanity Party were both outlawed by the Nazi. And in any case, Alexander was even following a school, a Steiner-style school there. So, because Haydn was against the Nazi, the Alexander, let me call it Alexander Grothendieck now, Alexander had to quit the home. Haydn home was closed, so he had to quit and to rejoin his mother. At that time, it was 1939. Alexander was 11 years old. He joined his mother in near Montpellier. We don't know anything about his father. His father was somewhere in Paris. World War is declared. And so at this point, you have to think that Anka was German, okay? Anka and Alexander Grothendieck, they were both German. And France was against Germany. Alexander Shapiro was he was a communist, let's say anarchist, and so on. So what happens? So first of all, Shapiro is arrested by the French police at the beginning of the war and sent to a prisoner camp close to Pyrenees, like all the other communists and all the other people who has fought in the Spanish Civil War, in Le Vernet. So remember Le Vernet, because this Le Vernet will come back later. After France was occupied, he was a Jewish, and so the German, they took him and they sent it to Auschwitz. So what he did, his father, the Alexander Grothendieck father, was to fight all his life for freedom and self-determination of the people. So the legend says that he was in prison in 16 different countries, nations, okay? And not because he was a thief. By the way, there is another, if you look at the Wikipedia, let's say now, Wikipedia, there is another Alexander Shapiro, which has been known in that period, was a really important anarchist. And it seems that at the end of his life, Alexander Grothendieck was not clear in detecting the difference between the two, between his father, nom de guerre Alexander Shapiro, and this Alexander Shapiro. Here, there are two pictures. So you see on the left, Sasha, which is one of the nom de guerre of Alexander Shapiro. And then this is a picture of Alexander Shapiro in the Vernet internment camp. At the start of the war, Anka was as I said, she was German. So she was put in he was put in the prisoner camp again in Mendes. Mende is not far from Montpellier. It's something, okay, we are in South Africa. For me, I'm Italian. For me, they are close. But perhaps for the French, and there are a lot of French here, they are not so close. But it's on the south. Let's say that is on the south of France. And of course, so think again, Alexander is there, and he had the possibility to continue to study, which is a kind of lucky situation again. In 42, Alexander is forced to quit his mother and to go in a remote village south of Lyon, close to, what is Grenoble, I think, that in the middle. And again, it's again an incredible situation. Again, I take myself all the time. Suppose that I have for some incredible reason to be forced to quit my mother and to be sent in some remote village. What should I will find in that remote village? Well, as things to do. Well, collect beets, mushroom, following goats, and that's the only thing that I could think that I can do. But in fact, not. For Grothendieck, he ended in an incredible place. The town was Les Chambon. It was a Protestant village, and it was run by Pastor Trocmé, which had, which I would say all the village was founded on ideals of non-violence and solidarity in a moment where the war was at the highest level. So then that's incredible for our Alexander. So think that the Les Chambon as a whole village hid Jewish people from the Vichy Nazi regime. The residents, all the residents, helped Jewish fleeing from the Nazi to the Switzerland. You have to think that Les Chambon is one of the two collectively towns honored by the righteous among the nation, the only two towns in Europe. So we have even a movie about this village. But what was doing Trocmé there? He had a lot of, he was helping all these Jewish from all over Europe. So he decided also to have an international private lycée there. And Grothendieck had the opportunity to study there, obtaining there the baccalaureate, which is the exam that you have in France in order to go to the university. Okay, not collecting bits, okay? So this is a picture of Trocmé. It seems that clearly he's a pastor. You see, he has everything to be. Okay, the war is over, and Alexander with his mother, they are both together in a place near to Montpellier. Alexander has not a passport, but yes, he enrolls. He decides to be a student at the University of Montpellier. They both survive using the scholarship of Alexander. Montpellier, even in spite of the fact that it is a really old university, at that time it was not in what we say now in a QS ranking, I think, something like that. It was not really a good university, even if in the Middle Age it was one of the best for medicine, and I think also for law, from what I understand. So, and then, he was bored by the teacher. At a certain point, he started to study the theory of measure. Theory of measure, okay, now I prepare myself. Is a way how to calculate the distance between 2 points when it's not possible to have a direct line between the 2 points. So suppose that you have a mountains, then you have to calculate the distance between the 2 points following the path, okay? So sometimes for the people who knows better, there's something connected with the geodesic, okay? So he decided to study this problem, rediscovering Lebesgue theory of integration. Nobody in Montpellier knew that he was a really well-known stuff. And again, okay, you said, okay, this is the end of the career of a mathematician of someone. He's in a place where he discovers something, and if you go just a little away, everybody know that result. So it's like that you do wonderful things here, and people they are using rockets and they go to the moon. But you are strong in here, just in a little piece of dust. Okay. So then, this is the end of your life, but not. Here, I think that the people in Stellenbosch, they will appreciate that Grothendieck, in order to earn his life, he was collecting grapes. So not so far from the real life here in Stellenbosch. Okay, so it depends if you collect or not. So that is not the end of his life. In 1948, he was sent with a recommendation letter to Élie Cartan to study mathematics. Alexander is 20 years old. Again, Élie Cartan was a kind of old man, or almost over 80 years old. So again, it can be the end. No, Grothendieck is received by his son, Henry. Henri at this time, Henri Cartan, at this time he was running a seminar, which we know as a Seminar Cartan, and which was the most advanced seminar, and they were dealing with the most advanced topics in that period in the world, more or less. Okay, but more important is the fact that people attending that seminar, they were really, really important. So, first of all, Henri Cartan told Grothendieck that the theory of integration is really well known, so we fixed the problem about, okay? But because Alexander could attend Seminar Cartan, he could speak with really important mathematicians. Suppose, me too, I'm sent to some university, I found sent to someone 80 years old, moving in a strange way, no son, because he was a mathematician or something like that. What I can do? Nothing, again, usually collecting bits, again. No, for him, was not like that. He was there, and there he could stay and listening to this seminar with André Weil, and remember that André Weil was a brother of Simon Weil, which was a philosopher, Jean Leray, Claude Chevalet, as well as a younger Jean-Pierre Serre, who got the medal fields in '54. Okay, then who got the medal fields later? Armand Borel, Pierre Cartier, Bruhat, and so on. So not just bits. Okay, and Cartan, so he was there, and at a certain point, Cartan sent Grothendieck to Nancy. Who were the people in Nancy? Laurent Schwartz and Jean Dieudonné. For us, they are really good mathematicians, but at that time they were really young. And Nancy was not Paris. It can be a tautology, but it's really, really deep, this story, okay? It's really something, okay? And Grothendieck decided also to go there with his mother. Schwartz gave to, okay, suppose even to be always me. I'm lucky. I go in some university. Some young professor gives to me his recent paper. There are some problems, open problems. They said, okay, try to solve this problem. Okay, if I'm lucky, I will solve them. If not, I won't solve it. But Schwartz, so Schwartz gave to Grothendieck this paper with 14 open problems. But Schwartz was getting 2 years later the medal fields, using one among the others, using that paper. So it was incredible. So this Grothendieck had the possibility to work on the open problem made by a medal fields. And in few months, Grothendieck solved all of them. So think about that. The guy that really young, he proved all the theorem and open questions asked by a medal field. Then, by the way, Grothendieck was really active. He became also a father from a relationship with his landlady, and his mother was there around. Okay, they were living all together. Okay. So think of that. So it was incredible, as I said, that unknown guy from obscure university, and the career was not from the École Normale, solving all the problems proposed by a medal fields. And as a matter of fact, in functional analysis, it took 15 years that the people in functional analysis started to use these nuclear spaces and complete a tensor product. Okay, then was a long time. For a long time, they didn't use too much. Okay, and here it is Grothendieck. He was really, really a fit guy, sorry. And this is the picture. So he got the PhD in Nancy in '53, but it was enough just to solve one of these problems to get the PhD, but he solved all of them. He was 25 years old. For a few years, he continued in the subject. And he was without a passport. It's true that he was born in Berlin, but after the Red Army occupied Berlin, all the documents that disappeared. He didn't ask to get back his documents, so he he has at the moment, he has the Nansen passport. So just a no nation, without nationality. So it was difficult to get a position. He had a position in Brazil, where he said that he had only, for 1 year, he had only milk and banana, and 1 year in Kansas, US, but there he didn't say what he had as a food. So perhaps it was worst. Okay, sorry, joke. Okay. Okay, so remember, Jean-Pierre Serre was among the people attending Cartan seminar, which got the medal fields in 54. He decided to work in algebraic geometry. He proved a theorem right away, called, now called, before it was not called like that. It was called Hirzebruch-Riemann-Roch. But after his new proof and generalization, nowadays it's called Grothendieck-Hirzebruch-Riemann-Roch theorem. He could speak at the ICM. ICM is International Congress of Mathematics. Every 4 years we have this international congress. In that international congress, the medal fields are given. Okay, and to be invited there is something. Okay, it's not so is to be a main speaker in one of these ICM. It's a really important thing. So he spoke about this theorem in 58 in Edinburgh. Alexander was 30 years old. Here it is a picture of him. Okay, so you said, okay, he's back, so perhaps he's getting a position. And but again, something a lucky opportunity appeared to him. In late 50, a businessman, Leon Mochan, which was impressed by the Princeton Institute of Advanced Studies, and he planned to have a similar institute in France. He founded also with the money the Institut des Hautes Scientifiques, which is known among the mathematicians like IHES, in Bure-sur-Yvette, which is on the south part in the suburb south of Paris. And look at this, he appointed Dieudonné as a leader scientist. Dieudonné was the guy with Schwartz who received Grothendieck from Paris, okay? So, and Dieudonné wanted Grothendieck to join the IHS. So wonderful. So it's if you think that in the Institute of Advanced Studies in the 50s, they had Einstein and other people, okay, not only Einstein, but here they wanted to do something similar. And one of the first guys who was invited there to be a stable member was Grothendieck in 58. And that's wonderful again. So among all the unlucky situation that he had with his family, he had some good points. He had some good opportunities, our Alexander Grothendieck. So Grothendieck starts a new and ambitious project of refounding algebraic geometry. He was helped by Dieudonné. The old master now is a kind of student, taking notes and writing the article. He begins the Éléments de géométrie algébrique between 60 and 67. They publish the first 4 chapters, and they are made in 8 volumes, hundreds and hundreds of pages each long. But as usual, mathematics, but he has also another life. He got married, 3 kids, and he decided for unconventional education for them, no public school. His house was open to people in needs, even for a week. But on the other hand, this part was a kind of anarchist part, but he also had an incredible routine style life. He was working every day 10, 12 hours, 7 days a week, all from all the week, no vacations, no movie theater, no newspaper, nothing else. Then he had also a really well-known seminar, which is called Séminaire de géométrie algébrique, the result of this seminar, this weekly seminar, along the line of Séminaire Cartan, some of the results are now in EGA, so in this book, in these several books, Éléments de géométrie algébrique, but this seminar, they have also their own books. There are 13 volumes, several thousand pages again. So it's really, really important literature. The best students of École Normale, they were there. Ilusy, Renaud, Berthelot, Deligne. And others were sent from the United States. Nick Katz, Messing, Arthur August, Mumford. He was really generous. He was talking about his idea in this seminar that was 1 day long, explaining his idea to everybody, ready to help, to discuss, and so on. So IHES was really the center of the world in algebraic geometry. Here there are 2 or 3 pictures of him as this is the IHS had the main building with a lot of offices, but he has also a pavilion with a lot of glasses like that, where you can see the woods around you. That's a wonderful place. Here it is again, giving a speech and a seminar. Okay, he was at the end. He was awarded himself by the medal fields in Moscow, but something is happening. He refused to go in Moscow because he said that he wanted to protest against the treatment of dissidents in the USSR. Okay, this is rather strange because before he was just studying. Of course, I told you the history of his family, but before he was just studying. No movie theater, no TV, of course. In the 50s it was easy not to have TV, okay, but okay, no TV, no radio, so something like that, okay. So, but he didn't do anything against the Algerian War. Algerian War was really a big thing for the French, for France. Even his thesis advisor, Schwarz, was really active trying to stop the war. He started to have a problem with Mochan. Mochan was the sponsor of IHS. And among others, also one of the new entry at the IHS, René Thom, which was medal fields in '58, and as you know, he was the guy who started the catastrophe theory. In '69, Alexander, he was 41 years old. He visited North Vietnam really during the war. After that, he came back and he started to speak about supporting North Vietnam. Let me give a picture of him expressing. You see here you have a home hunter, and of course all of you. So this is a joke for the people, for the general audience. Home hunter, everybody knows about the home hunter. He was teaching at the Vietnamese people here in this class. You see, wonderful class. It seems that according to Grothendieck, during one of these lectures, the class was bombed. Some of the students died. Okay. Then this is Grothendieck visiting a village. Take a look at that now. Is completely without hairs, more or less like his father. Okay. So think about this. Grothendieck was in Vietnam, coming back, and Paris was the center of the '68 protest. He became very concerned about environment, the nuclear threat, and the arms race between USA and USSR. In 1970, at the age of 42 years old, he suddenly resigned from the institute where he was, and he left, saying that he was leaving math. For sure, he left the math as he did before. In fact, the reason, but we will discuss later the reason of this decision, was because he discovered that IHS was partly financed by the French Ministry of Defense of Army, let's say, from the army. And because he was a pacifist at that moment, so he couldn't stay there and be paid by some army ministry. Mochan didn't do anything to stop him. In fact, they were not in a good relation at that time. He was supposed also to speak at the ICM in Nice, organized by his really sponsor, by Dieudonné. At the same time, he was founding an ecologist, environment, and a pacifist movement, Survivre et Vivre, so which is an international movement for the survival of the human species. So he was really thinking at that moment about the fact that humanity was going to disappear. Grothendieck is, let me call it Grothendieck directly, not anymore Alexander Grothendieck, is totally engaged. He leaves his wife and the 3 children, and they decide to live in a commune, you know, the classical lifestyle that you had at that time in the 70s among the young people, okay? When invited to conferences, like, for example, in ICM in Nice, he really insists not to speak about mathematics, but mainly about ecology, nuclear weapons, and so on. It started to quarrel against. With all the other friends, old friends. So it's really start to be far from the rest of the other mathematicians. Here it is a classical 17th picture. You see Grothendieck in the middle. On the right-hand side, you have a Buddhist priest and some other friends in the commune. So that's the result. He left the ITS, and now he's going back. Let's see what happened in his life. He's going back to its roots. So in '73, he moves to a village near Montpellier, the university, where he took a position as a professor. Montpellier at the time was not in QS ranking again. It was always outside. There, he teaches sometimes, not in a regular way, but he spends all his time in writing in a kind of strange way, a kind of mathematical meditation, which are known as récolte et semaille, harvest and sowing. There are thousands of pages written in a Joyce-style stream of consciousness. They are recollection of his life as a mathematician, complaining against some of the people who followed his seminar. But sometimes there are little hints of mathematics. But don't think about theorem, proof, and so on, lemma and corollaries. In the meantime, as usual, he had another child in a new relationship in one of these commune where he was living. Okay, but from my point of view, he was not really not doing mathematics, but it was a different way as he was doing before. Before he was doing in a systematic way. He wanted to construct a whole landscape for the mathematics, for the new algebraic geometry. Now he started to write some let's say books in mathematics. It will be too much, but some ideas about mathematics, and the works are really amazing. Let me describe some of them, actually all of them. So we have La Longue Marche à travers la théorie des schémas. It's 1,600 pages. It's the long path toward through the theory to the scheme theory. Scheme, something that will appear later. This is not a book of mathematics, but it gave rise to a new branch of mathematics that we call abelian geometry, which is still now very active in Japan. We don't discuss about ABC conjecture now, okay? Just generically, okay? In 83, Alexander was 55 years old. He writes à la poursuite des champs, chasing the fields, is 600 pages of new links between algebraic geometry and algebraic homotopy theory. This was a kind of extension of some grant application that he wrote, which is a schist-down program, hint of a program, in which you have also some extension of Galois theory. Finally, in 1991, he wrote Les Dérivateurs, the derivations, something like that, a 2,000 pages manuscript. And in that manuscript, there are some ideas which has been developed by Vladimir Voevodsky later, who got the medal fields in 2002. Here, one of the picture of Alexander Grothendieck in the late 80s. So, Grothendieck retired in 1988, 60 years old. He retired from professorship in Montpellier. He moved to the even small remote village around Montpellier, and later in the Pyrenees, not far from Le Vernet. Le Vernet was the prisoner camp where his father was before being taken to Auschwitz. So, and he had minimal contact with the rest of the world. He devoted himself to spirituality. You saw before in the 70s he was a Buddhist, but after he turned himself in some kind of Christian mysticism. He fasted too much, sometimes nearly dying in the process. Why? Because he wanted to experience the conscious death. So he wanted really to know to be dead, but still to live. Okay, that's interesting. So in 2010, he asked to stop the sale of all his work. And in one sense, he ordered that all his books were withdrawn from all the libraries all over the world. He started to write, I don't want to, this part I'm not so interested in it. So there are people, if you look at the biography in general, they are really concerned about this part of his life, but I don't think it's something interesting for us. He wrote pages, a page of meditation, play, poetry. The title of one is La Clef de Songe, the key of the dream. Okay. He died in 2014 in Saint-Giron, which is not far from Le Vernet. Here is a picture. For the French is stupid, but here I am in South Africa, and if I see a map of South Africa, I couldn't understand where one place is. So it's good, I think, that for the people here to see. So Nancy is there. You see, far away from Paris, and mainly that in a northern part of France. Here, Paris. After you have Le Chambon here, so Montpellier is here. You see, Montpellier. Le Vernet was close here to the Pyrenees, and Saint-Giron where he died. So there are some ideas about this excuse that the ITS was founded by the army. I'm not so sure that it was the only one and the principal one. I think that we can also think about a burnout. After working 12 hours a day for 7 days a week for 20 years, okay, and seeing that the landscape that they want to create is growing and growing and growing, perhaps at a certain point, someone can be really tired of it. So also the feeling of having betrayed the ideals of his parents. The parents, they spend all their life with this ideal of anarchist. But at the end, Grothendieck, when he was at the IHS, he was a rich guy, a full recognized professor, having a normal life. Perhaps that was another possibility. But on the other hand, I stress a lot the fact that he was lucky. but no way that we cannot avoid to say that he was also unlucky. 5 years old, he was left at home. His father and his mother, they were away in France. 11 again, and so on and so on. That's not an easy life. And so these kind of things, after a while, they came back. Okay, so that's all. But I don't think that this is the main point of the life of Grothendieck. So among these, so when we see his life, we see that there is this idea so if you think this idea in his parents, in himself, thinking about also big things like pacifism and so on. So in mathematics, oh, by the way, this is one of the last picture of him when he was becoming trying the conscious death. Okay, so the mathematics of Alexander Grothendieck. So what I don't have the time with me here. I have 50 minutes. Good, good. So Grothendieck has changed the mathematical landscape and gave a new philosophy in approaching mathematical problems. Algebra, geometry, number theory has been completely transformed by his idea. So if you think the theorem like André Weiss in the Fermat last theorem, it would be impossible to be proved without the help of all the scheme and a new kind of arithmetic algebraic geometry that Grothendieck have introduced. He got the medal field in 1966, but later, Deligne, one of these guys following his seminar, got a medal field in 1978, proving completely the Weil conjecture. Faltings in 1986 with the Mulder conjectures. All these medal fields, they are really connected with his work. But even nowadays, if you think nowadays medal fields in algebraic geometry, they are really, without his work, without his way of thinking mathematics, without his, let's say, landscape of EGA and so on, then this kind of result couldn't be possible. Grothendieck was motivated by theories. So a specific problem should be seen as a small part of a big theory. He was not really, he didn't want to solve a problem by brute force or by skill, but he wanted to put this problem inside a theory. He was really interested in the Weil conjecture, and the Weil conjecture was something that it was a good place where to show this fact that you need a big picture to understand the particular situation. As I said, these Weil conjectures, they were proved by Pierre Deligne. His philosophy was to deeply understand the underlying structure and remove all unnecessary backgrounds, so to release the problem in a natural context, where the problem would dissolve and find an almost tautological solution. So if I can make a kind of comparison, taken from the Bible, it's like the Jericho walls. So Jericho walls were, so some people, they wanted to destroy the walls. They try for months and months with the usual weapons that they used to have, with attack, with soldier and so on. But at a certain point, it was clear by someone who told this army that it was enough to have a wonderful parade around the walls and playing some trumpets of horns, and the walls, they will dissolve. So the attitude of Grothendieck was something like that, in such a way that the landscape was so clear, and the problem was inside this landscape, that the solution, they were almost tautological. More than the solving a problem, Grothendieck's attitude was to formulate a global theory in which such a problem was only a little part. So let me give a picture. So this, you see a country known only by a name. This is a title of one of the famous biography, mathematical biography of Grothendieck, written by Pierre Cartier. And you see, here you have Jean-Pierre Serre and Grothendieck, and the chair in the middle. So the attitude of Grothendieck was to think to something. At a certain point, it was clear for him that there was something that should have been discovered, which should have been detected. And in general, he was really good at giving a name. And so this picture gave us something like, I know that there will be someone there. And so let's put some mathematical landscape in the middle, and let's wait to discover what is really the problem is. So a country known only by name. If I have more time, I also have some hints to be more precise on what I mean in terms of mathematics, and what I mean to prepare a landscape for a problem. Okay, so I would like to if I have some more time, how much? 5 minutes, so I think that I can do that. So I would like to introduce the Weil conjecture. So, and so I would like to introduce the idea of schemes and motives. Okay, okay. So don't be scared. But no, you are mathematician, a lot of them. So a lot of you are mathematicians, so you are not so scared about that. But okay, you are used to have when we consider the plane, Cartesian plane, we are thinking about couples of real numbers. Or if you think about the space, the continuous, our continuous space, we take the triples of real number. Of course, when we take an equation like that, we are thinking about in the plane, we are thinking about a circle, x squared plus y squared equal to 1. Then, in the 19th century, Riemann studied the solution of a polynomial equation and introduced what nowadays they are called Riemann surfaces. What was the idea? Not only to study equation as before on the real number, but also in some extension of the real number, what they are called the complex number. These complex numbers, they are numbers where you can solve all the equation. Okay, so he said, okay, let's study the equation x squared plus y squared equal to 1 in this instead of couple of real numbers, let's study with a couple of complexes. And then he got the sphere, which does not have holes, as you see. If you make the things more complicated, if you add some power to the power 3 for the x variable, then, not always like that, sorry. So I know that among the mathematicians that is not always like that, but let's say, then you get what is called a torus, or an elliptic curve, which has one hole. If you make higher the degree, here it is, now we have y squared and ax, this time is to the power 5, then you get elliptic curves, in which two holes. Okay, and you can go on in this way. Holes are invariants. Riemann found that these are the invariants of this equation. And they also remain no matter which reasonable transformation we make. So of course, if we destroy the things, we don't see any more holes. But if you have some reasonable transformation, in this case, holomorphic transformation, then no matter how we move our object, the holes, they will remain all the time. But so what we did so far? R in this C, we have multiplication. We can add. We can do this kind of things. But there are different settings, not only in R, in the real numbers, but on the complexes, but we have different settings. We have fields sometimes where we can solve the same equation. What do I mean by fields? Here it is the example. So it's not a field, okay? But so we take F12, okay? Sorry, but I said that it was for the general public. Okay, it's not a field. Okay, don't look at me strangely. Okay, but there we can do operation. 7 plus 6 is equal to 1, right? So 3 by 4 is 0. So 3 is 12 is 0. 5 times 4 is 20. 20 is in this set where you have only 1, 2, 3, 4, 5, 7, up to 11, and after you come back to 0, is equal to 8. 7 plus 7 is equal to 2, and 3 plus 9 is, after 9 hours after 3, is 0. So 9 is equal to minus 3. So if we are lucky, we can do all this kind of operation, and we can solve the same problems in this world. So we may have a similar clocks like Fn, and n equal to t, 3, 4, 5, 7, 70, 153, and so on. But if n is a prime number, we don't have anymore the case in which two numbers, they are multiplied and they are equal to 0. And this is where we would like to study our equations. So remember that, think that Fn has n elements. We can do also the same trick for if we take 1 prime, we can take the field Fp, but we can form, and this is difficult in general, I cannot explain to you now, that you can make a field of p square element, p to the power 3, p to the power 4, and so on. So if I take p equal to 2, which is the first prime number, if I take p equal to 2, which is our first prime number, I have F2, which has 2 elements, F4, which are 4 elements, and F8, which has 8 elements. So instead of working with R, we work with F2. Instead of working with R, we can work with F4, with 4 elements, and with 8 elements, F8, and so on. So instead of working with R to the power 2, or C to the power 2, we can work with Fp to the power 2, Fp squared to the power 2, Fp3 to the power 2, and so on. So let's see what F2 to the power 2, F4 to the power 2, F8 to the power 2 look like. So F2, so we have, before we started with this picture of the Cartesian plane. It was made by couple of real number. Now we have only couple of element of F2. F2 is made by 2 elements. So at the end, F2 square is made by 0, 0, 0, 1, 1, 0, 1, 1. So here it is the picture of F2 to the power square. X, Y are the coordinates line, and we have these 4 points. It's not a discrete situation. It's just these 4 points. So the word is made by these 4 points. If we look at the F4 to the power 2, the word is made by these 16 points. And finally, F8 to the power 2 is made by these 64 points. Nothing in the middle. It's not a discrete situation. This is the word. And we want to solve the equation that we had before. Here it is the picture of x squared plus y squared equal to 1. They are the couple of elements in F2 which satisfy the equation that I am writing there. It's given by the 2 red points. Okay? Then, if I want to solve the same equation in F4 to the power 2, I have these 4 points. And if I want to solve the same equation in F8, that is given by these 8 points. You see, in one sense, in the over R over C, we have a sphere. Here we have numbers of points. Okay? So how to connect, and this is in a light way, what the meaning of the Weil conjecture. How to connect the shape, the holes in the real world, in the complexes, with these numbers of points. How you can, looking at the numbers of points, of course not only at the numbers, but looking at the numbers of points in F2, how you can say from the beginning that the equation over C, over the real, has 3 holes, 4 holes, and so on. This is really the meaning of the Weil conjecture. And here it is the idea of Grothendieck. Okay, you have this problem, which is just look at the points in this world in which you have only number of points. You don't have continuity. You have a number of points. And the idea of Grothendieck was to introduce the notion of scheme, which was a homogeneous landscape for all these things. So looking at what happens in the field in the characteristic P in F2, this is one part of a global landscape which is given by the schema, which has also what happens over the reals. So in the case of x squared plus y squared equal to 1, the scheme is ruled by the equation. And no matter where we look at it, in C over Fpn, we will get the same information at level of invariant, all twisting. Of course, the same information, they are given in different way, but they are the same information. Okay? Why? Because we have this kind of homogeneity of the schema, which is inside the name of the motives. It's here it is perhaps my interpretation of the motives. It's not only mine, but in fact, what we are seeing when we pick the equation, studying it on F2, F4, F8, it's like that we detect some information from here. We are playing a motives using one instrument. And because the motives is made by musical notes, okay, we can listen to that, which has the sound is different, but we can understand what will be the sound of the same motives played by another instrument in another side. So in one side, you have the instrument played by F2, F4, F8, and you have some hints. Then you detect the notes. At that point, when you go to play the motives using R or C, you know from the beginning what the notes will be. Okay, that's one little idea about a country known only by name. Thank you very much.
Much for a great talk. Very, very interesting and entertaining. Maybe since we have maybe -7 minutes.
Oh, okay. I was
scared
not to be.
Some urgent ones. Please raise your Zurab. I would have been disappointed if it wasn't you.
Thank you very much indeed for a very nice talk. Do we know why did he want to withdraw his works from libraries?
No, I think that at that time it was I didn't get through too much in Récolte Semaille, all these things, but in Récolte Semaille it was really, he was disturbed by the behavior of all his let's call it them students. Students was one of the students was Deligne. At that moment, he had also medal fields, Katz, all these people, they were his students. He was really disappointed. So he said that you are not following my path. You are not completely prove what we need for my complete landscape. He was complaining about the fact of the proof of Deligne of a veil conjecture, which he said, no, it's just a little trick. You didn't do what you were supposed to do. So at that point, he said I did a lot and nobody is following me. I don't want anymore to share my ideas. And also he was against something, but in one sense, this ecologist idea, this coming back to, so he was like someone who did things before the others, okay? So if you think in the 70s, the people, they were concerned about war, pacifist, because they had, some little ecologists, but not at the level of Greta Thunberg style, okay? But Grothendieck was at that time. He was really concerned about ecologists, about human, survive vivre means that we should survive as a human species, not only because of the nuclear threats, but also because we are wasting we are destroying the nature. Okay, so for the same reason, he was against the publisher, I think, also Springer or these things. He had a lot of fights against Springer also.
Thank
and
you.
nowadays also we had this kind of fights against these
Sure, yeah.
publishing houses.
Any other questions? Yeah, please. Sorry, microphone is coming.
Thank you for the talk. So I would like to know, in your opinion, what would he think or what would he feel about the development of AI?
Because perhaps you have noticed that I have some AI here. I think that I use AI only in not what you expect, perhaps. Here, these things, they are made by AI, ChatGPT, these things, okay? This is, yes. But in fact, no, may I? In fact, what I did is I tried my experience, so I draw it. I draw by myself. I made a calculation using, okay, there you saw we are mathematicians. So to describe this, it means that I decide to, for example, for F8, I had to say what is one element. I didn't say anything about, okay? So I describe that, I made a picture, I take a picture with my mobile, and after I ask to ChatGPT AI to transform in a LaTeX way. Yes. So I think that he will be against, I am sure.
I know that you couldn't see it, but there was lots of clapping from our online audience. Oh. But I didn't see any question from the online audience. Oh, or is there one? Yeah. Yeah, please.
Yeah, I think the question was, which work by Grothendieck did you enjoy reading the most?
I think I'm not so strong in title, but is when introduced this idea that algebraic, okay, if you are, may I? So I like this idea that if you have an equation, as you see, then the solution of the equation, a polynomial equation, they give to you an algebraic variety, okay? And in this algebraic variety, you have a Zariski topology. Zariski topology means that you have just polynomial things. And after using polynomial things, and that's something, okay? But the same equation can be seen, as we saw following Riemann, can be seen in holomorphic style. So it's an analytic variety. And then you have the de Rham complex, you have C infinity things, and so on, okay? And then you can calculate the de Rham cohomology, and you get holes and so on. And but he proved that you don't need, this was really at the beginning, the 66 articles in ITS, how do you call no analysis of ITS, but the publication of the publication de l'Institut d'études scientifiques. Then you can prove that you don't need to know how many harmonic differentials you have in this analytic variety. So you don't need to use C infinity things. It's enough to stay in the Zariski topology. It's enough to use only polynomial things to solve all the problems that you have. So the de Rham cohomology which is given by C infinity function, can be calculated using only polynomial functions. That's really, to me, it's really important. Which is kind of development of Gaga style theorem. Gaga is not a singer. It's geometrie algebraique and geometrie analytique. That's the...
Okay, then I think it's the time to thank you very much for your nice talk. And I would like to give you a copy of magazine that NITheCS supports and the editor is sitting here. She will out herself later. Yeah.
Okay.
Just to popularize mathematics in high school. So thank you very much for your talk.
Thank you very much.
And according